This is going to be 8.6 and 8.7 parametric equations. So far we've been kind of talking about things that are functions. So we have y equals f of x. So this is kind of what we've been working with. So now we're slowly going into the world of where functions or particular graphs are not functions anymore. So we're going to start off with something called the particle moving along a curve. So let's say we have a particle moving along a curve. And typically, parametric equations appear a lot in physics and in Calc 3. So you'll see this again in Calculus 3 if you go there. So basically, the idea is that, let's say you want to model the a particle's movement. So maybe it looks kind of like this. Goes this way, then it goes back, and then continues on. So you have like this curve. We're going to call this curve C. So usually the way that we can model this particle is that we can kind of draw arrows to indicate the direction in which the particle is moving. So if I were to look at this base curve, you can see that this curve can't be it can't be described in terms of f of x. So it's going to be very difficult to describe C by y equals f of x. So that's not going to be possible because, for one, it fails the vertical line test. Fails the vertical line test. I'm going to write VLT for vertical line test. So you can see that here you kind of have a failure there. So instead, what we're going to try to do is, one of the things that we can remedy this is to express x and y by another variable. So basically what you're going to do is you're going to describe the movement in the x direction. So you can see here the x direction doesn't really move, and then it slowly moves this way, right? And then it doesn't do it anymore, but then it goes back. So basically I'm expressing just x by itself, and in the y direction you can kind of see that the y is moving. Then it stays, and then it moves again, and then it moves again, and it slowly stays. So instead, what we're going to do, instead of trying to combine both of these together, we're going to express them with another variable. And the other variable is going to be t. And t here is what we're going to call the parameter. So it can kind of be like the time, if you can think about it that way. So the goal here is to express the x variable, and we can write it as x of t, as another function, f of t. And you want to express y of t, or the y variable, in terms of a function, g of t. These things are what we call parametric equations. So these are parametric equations. Okay, so these parametric equations, what they do is that when I graph them, I'm going to get the space curve. Okay, so you see this a lot in physics when you're trying to model projectile motion. So if I'm here and I threw a ball and it kind of follows this parabolic shape, then notice that I can definitely express it in terms of y equals f of x. For sure I can. But another way that I can do it is I can express this with x and the y variable. So x being the x being the horizontal distance, and y being the vertical distance. So I can kind of figure out, okay, the vertical distance is going to be expressed in terms of y, the horizontal distance is going to be in terms of x, and I can model it at different times. So this can be time equals 1, time equals 2, time equals 3, time equals 4, so on and so forth until the ball finally hits the ground. So here's another way that we can kind of look at parametric equations. So I guess right now the question here is how do I convert a function to a parametric equation? So how do I convert a function to parametric equations? So in order to kind of do this, there's usually a really easy way to do it. One way is to just let x or y equal t. Okay, so just let x or y equal t, and then plug that into the other equation. or the original equation, I should say. So that's basically a really easy way to kind of parameterize something. Now, the thing about this is that this is just an easy parameterization, but you can have different ways to parameterize a curve. So let me give you an example. So let's say you're given the following. So you're given y equals 3x plus minus 1. So you have this equation of a line. So let's say we want to parameterize it in terms of the time. So one way that we can parameterize it, so let's say parameterize the curve. Or convert it. Parameterize is just another way to kind of just say, convert this to parametric equations. So one way that you can do it is you can just let x equals t be your x value. And then what you're going to do is you're going to plug in x equals t into the original. I'm going to plug in t in there. So y is equal to 3t minus 1. So basically my set of parametric equations would be x of t is equal to t, and your y of t would be equal to 3t minus 1. This will be my set of parametric equations. Okay, so is this the only way that we can parameterize a curve? No, I could have easily said, let x equals 2t plus 1. If I let that happen, then y is going to be something different. So now what I'm going to do, I'm going to plug in 2t plus 1 into x. Then you're going to have a minus 1 on the outside. Do a little bit more work. 6t plus 3 minus 1. So you're going to get 6t plus 2. So that means that my parametric equations for x was 2t plus 1, and for y was 6t plus 2. So actually, these two, even though they look very different, they will still shape this curve. So when I were to graph them, and we're going to graph them in a second, this is basically going to give you this curve. So it doesn't really matter what you want to let x equal to. I could also have said y equals t. I could have said x is equal to ln of t. Okay, and then when you plug it in, you will just have 3 ln of t minus 1. So I could have done any different type of parameterization. It doesn't really matter what I plug in for x or what I plug in for y, as long as you're using this original equation as well. Okay, so that's basically how you parameterize. It's nothing too difficult. Okay, so let's start by sketching a couple of parametric equations. So let's sketch. Let's see what these graphs kind of look like. So sketch and identify the curve defined by parametric equations. And here are the parametric equations. X is equal to, or let me write x of t. X of t is equal to t squared minus 2t, and then y is equal to t plus 1. Okay, so the first thing that you kind of want to do when you want to sketch is the way that you want to do it is a really easy process. Oh, I forgot the y of t. The way that you kind of want to do it is you want to start off by making a table. So you're going to start off with your x coordinates. Oops, that's wrong. You're going to start out with your t coordinates. So you're going to plug in some values of t, then get some values of x's, and then get some values of y. So to start off with t, it'll be smart to put in some values that are negative. So I'm going to plug in -2. I'm also going to plug in -1. I'm going to plug in 0. 0 is a good number. Then I'm going to plug in 1. I'm going to plug in 2, and I'm going to plug in 3. So the more points, the better. Okay, so now what I'm going to do, I'm going to plug in -2 in here. So I'm going to have -2 squared minus 2 times -2. That's going to give me 8. And I'm going to take the same -2 and plug it in here. So -2 plus 1, that's just going to give me -1. Okay, then I'm going to plug in -1 into the x. So -1 squared gives me a 1 minus 2 times -1. That's going to give me a 3. Then -1 plus 1 is going to give me 0. Then I'm going to plug in the 0. This is just going to give me a 0. Plug in the 0 there, I get a 1. Then I'm going to plug in the 1. I'm going to get 1 squared minus 2 times 1. That's going to give me negative 1. Then I'm going to plug it in there. That gives me a 2. Then I'm going to plug in the 2. That seems that's going to be 4 minus 4, which is 0. And then I'm going to get 3. Then for the other one, I'm going to get another 3 and then a 4. Okay, so it's just a very tedious process. You just have to plug a couple things in. Now let's go ahead and graph it. So we're going to graph it in a regular x and y. So this is how you're going to graph it. So the first thing is that these points that I just found out are basically coordinates, x and y's. So if you kind of want to think about it like this as coordinates, they're going to be really easy to graph. Let's not worry about t just yet. So we're first going to graph 8 comma negative 1. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8 comma negative 1. So I'm going to plot that. Okay, then I'm going to plot 3 comma 0. Okay, so here's 3 and then comma 0. So there's no movement there, so it's going to be right there. 3, 0. Then you have 0, 1. So here's 0, here's 1. Okay. Then you're going to have negative 1, 2. So negative 1 is out here, and then 2. So you're going to have that. And then you're going to have, okay, and now let's plot, where am I? Negative 1, 2, we just plotted that one. 0, 3, so here's 0, and 3 is going to be up here. And then 3 comma 4, so here's 3, and then all the way up to 4. So what you can see is that you're kind of shaping this type of curve. So the way that we're going to do it, the way that we're going to plot it is going to be in the direction of t. So t starts off at negative 2 right here. So here's t equals negative 2. Then it goes to t equals negative 1. Then it goes to t equals 0. T equals 1. T equals 2. And then t equals 3. So you're going to go ahead and trace the points as they are going, as they are tracing. So you're tracing this as t is increasing. So you can kind of see something like that. Now, notice that this is going to continue going over there. You know, we just ended up just plugging in a couple points. And what you want to do is you want to draw arrows in the direction of increasing t. So I'm increasing in this direction. So I'm going to draw these little arrows to indicate the movement of this particular particle or whatever the heck this is. Okay, so this actually is the space curve. So we call it a space curve. Okay, so you have this type of curve, this contour. And this is basically what you're going to be doing. So now what exactly is this? Well, this looks a lot like a parabola, but it's sideways. So it's basically a parabola. But the parabola is going in the opposite direction. It's going in this, it's opening the other side. And we're actually going to talk about these types of parabolas later on when we get to conics. So yeah, this is how you would graph it. Now let's say you wanted to find actually, before I get to that, let's say you wanted to restrict this. So sometimes you're going to get a restriction on t. So maybe the t is only going to be between two numbers, maybe from 0 to 3. Well, if it was from 0 to 3, then that means that we're only going to get this part of the graph. So let me put it in a different color. So if there's some particular values that they want, then that means the graph is going to be shading from 0 all the way to 3. So this graph would be the one that I would want if there was a restriction on t. Now, sometimes they're going to ask for it, sometimes they're not. So if you have 0 to 3, then you're only restricted to the values from 0 to 3. But if there's no restriction, then you can plug in any values of t that you want. Okay, so now in the next video, what we're going to do, we're going to finish up parametric equations. I'm going to show you how to eliminate the parameter, and then we're going to do a couple more graphing problems.